In Lesson 6.1 Part B, we will be looking at how to find and interpret the maximum and minimum values of a quadratic function. The y-coordinate of the vertex of a quadratic function is the maximum value or the minimum value obtained by the function. The graph f of x equals ax squared plus bx plus c, where a does not equal 0, opens up and has a minimum value when a is greater than 0 or positive, opens down and has a maximum value when a is less than 0 or negative. So again, graphically, opening up, a is positive, so we have minimum value, opens down, so a is negative, so our vertex is a maximum value. Consider the function f of x equals negative x squared plus 2x plus 3. Determine whether the function has a maximum or a minimum value. Well, a is negative 1, so it is going to open down. So that means our vertex is going to be a maximum. State the maximum or minimum value of the function. Okay, we've got a equals negative 1, b is 2, and c is 3. So we're going to put it in to find where our x value, x coordinate of the vertex is going to be is at negative b over 2a. So we've got negative 2 over 2 times negative 1 is just going to be 1. So to find the maximum value, we need to plug that back into our original function. So we're doing f of 1, in this case, is negative 1 squared plus 2 times 1 plus 3. So we've got negative 1 plus 2 is 1, plus 3 is 4. So this graph will have a maximum. When x is 1, the maximum value will be 4. The terms minimum point and minimum value are not interchangeable. The minimum point on a graph of a quadratic function is a set of coordinates that describe the location of the vertex. So something that looks like this one, it would have been 1, 4. The minimum value of the function is the y-coordinate of the minimum point. It is the smallest value obtained when f of x is evaluated for all values of x, or in this case it was a maximum value of 4. A souvenir shop sells about 200 coffee mugs each month for $6 each. The shop owner estimates that for each 50 cents increase in price, he will sell about 10 fewer coffee mugs per month. How much should the owner charge for each mug in order to maximize the monthly income from their sales? The income, they called I of x, is always means equals the number of mugs sold, which they said would start at 200 and drop 10 for each increase, times the price of the mug, which was $6, and you're talking about increasing it 50 cents. We need to FOIL that out. I'm just going to go with y because we're used to seeing that. 6 times 200 would be 1200 plus 100x minus 60x minus 5x squared. Let's rewrite it in descending order of the variable that we're used to seeing it in. So we'd have negative 5x squared plus 40x plus 1200. So our a is negative 5, b is 40, and c is 1200. To find the x-coordinate of my maximum, we're going to substitute in 40 for b and negative 5 for a. So negative 40 divided by negative 10 would be 4. So 4 was the number of 50-cent increases we were going to make. So 6 plus $2 would be $8. What is the maximum monthly income the owner can expect to make from these items? Well, we found we're going to maximize our income when we make 4 price increases. So we're going to have -5 times 4 squared plus 40 times 4 plus 1,200. And we're going to type that in the calculator, and we get a value of $1,280. And I check the answer graphically by typing in the function -5x squared plus 40x plus 1,200, and then GeoGebra labeled that f. And it gives me an option of doing the maximum of a function, and it's labeled function f, over an interval, and I gave it the interval 0 to 20. And wouldn't you know, it gave me a maximum value at 1280, which is exactly what I got by calculation. The graph of y equals ax squared plus bx plus c, where a does not equal 0, opens up and has a minimum value when a is positive, and opens down, and the function has a maximum value when a is negative.